Have you ever wondered how gravity works? That force that keeps our feet firmly planted on the ground and prevents us from floating away into outer space? Well, today we're going to explore the fascinating ways in which gravity works to keep us grounded. Sir Isaac Newton developed his theory of universal gravitation in the 17th century, according to Newton. Every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simpler terms, this means that the more massive an object, the stronger its gravitational pull, and the closer the objects are to each other, the stronger the gravitational force between them. Let's take the Earth and a person standing on it as an example. The Earth has a mass of approximately 6 Ya kilograms, while a person typically has a mass of around 70 kilograms. If we assume that the person is standing at the Earth's surface, which is about 6,000 kilometers from the center of the Earth, we can calculate the gravitational force between them using Newton's formula. Plugging these values into the equation, we get a force of approximately 700 newtons. This is equivalent to a weight of about 70 kilograms, which is roughly the person's body weight. Now, you might be wondering what happens if we move away from the Earth's surface. The distance from the center of the Earth increases. The gravitational force between the Earth and the person decreases rapidly. In fact, if we double the distance, the force becomes 4 times weaker. This means that the further away we go from the Earth, the weaker the gravitational pull we experience. However, there's a catch. As the person moves away from the Earth, the number of atoms in the Earth that they are closer to also decreases. This reduces the total gravitational force acting on the person due to the Earth's atoms, but not as rapidly as the decrease in gravitational force between the Earth and the person as a whole. Consequently, there is a point known as the Roche limit beyond which the gravitational force of the Earth is weaker than the gravitational force of its constituent atoms on the person. At this point, the person would start to experience weightlessness. For the Earth, the estimated Roche limit is about 9,500 kilometers from the center. However, even at this distance, the person would still be under the influence of other celestial bodies, such as the moon and the sun. In fact, at any given time, the person would be experiencing the gravitational pull of all the celestial bodies in the universe. However, the gravitational force, due to these distant objects, would be too weak to produce a noticeable effect on the person. It's important to note that Newton's theory of gravity has some limitations. It doesn't explain what causes gravity in the first place, or why the gravitational force is always attractive, and never repulsive. Moreover, it doesn't account for the behavior of objects at very high speeds or in extremely strong gravitational fields. These issues were later addressed by Einstein's theory of general relativity, which provides a more comprehensive explanation of gravity. According to Einstein, gravity is not a force, but rather a curvature in space-time caused by the presence of mass and energy. Objects move along the shortest path in space-time, which is influenced by the curvature caused by nearby massive objects. While Newton's theory is still widely used because it is simpler and more practical for most everyday calculations, Einstein's theory of general relativity is more accurate and is necessary to explain certain phenomena, such as black holes and gravitational waves. In conclusion, gravity is a fascinating phenomenon that keeps us grounded on Earth. It is the result of the gravitational force between all the objects in the universe, with the Earth's gravity being the dominant force in our everyday lives. While Newton's theory of gravity has been superseded by Einstein's more comprehensive theory, it still provides a useful framework for understanding the basic principles of gravity. So the next time you take a step, remember the incredible forces that are at work, keeping you firmly planted on the ground. Thank you for joining us on this journey through the fascinating world of physics. If you enjoyed this video, don't forget to subscribe so you never miss out on our latest content. We've got plenty more videos that explore the wonders of the universe just like this one. So click the link below to continue learning about the amazing world that surrounds us. And who knows, you might just discover something that makes you say, "Wow, I didn't know that before." Until then, keep asking questions, keep exploring, and keep discovering. The universe is full of surprises, and we can't wait to show you more of them.